geometric, which we learned that there's this formula. It can be used, but I just said you could use summation on your calculator. You don't have to use this finite formula. We have a calculator that can do that summation. So we don't really need this formula. And it says, suppose you invest $100 every month in an interest-bearing account that gets 3% annual interest rate, which is 0.25% monthly interest rate. Remember, they take the annual interest rate, divide it up over the 12 months, and that's how much you're getting for your monthly interest. They don't give you 3% every single month. So the amount of money that you have would take this form. So let me just backtrack. If you put money in the account in January, right, you don't get any interest in January. Oh, just dropped my stack of yearbooks. Okay. So January, you put in $100. You don't get any interest. What happens in February? You put in another $100, but you get interest on this money, right? So this times 1.0025, because that would be your 0.25%, right? I don't get 2.5% interest, I get 0.25%, right? Which is what they're showing you in this pattern. So this is February's money. This is actually January's money that just got interest. So what happens in March? March, you put in another $100. What happens to your February money? Now your February money is being multiplied just by the 1 month of interest. And what happens to your January money? Your January money is now getting interest for the 2nd month in a row. So that's where this list of terms is coming from. Whatever month you're on, this is just your monthly input. Maybe this is April's money. March is now getting some interest. February is getting double the interest, and January is getting triple the interest because it's getting interest in February, March, and April. This is really what people do when they're investing. They don't just put in $100 and forget about the account for 10 years. They do a direct deposit of whatever. It might even be $25 out of their paycheck. The way that you do a savings for retirement is you do every single paycheck automatic withdrawal to your retirement. So it says, since in these cases the monthly return rate will be greater than 1, we can only find the sum if the series is finite. So I have to tell you how many months I'm doing it for, right? I can't do it for infinity. All right, so we're actually going to skip using their formula, and we're just going to use the calculator to determine the amount of money in the account after 4 years. How many months would 4 years be? How many months? Right, we're doing monthly, so isn't that 48 months? So I want to show you what this looks like as a summation. Your summation is going to go from 1 to 48. You just told the person how many compounds you're doing. What are you investing? You're investing $100 every single month. And what's the interest rate? The 1.0025 to the n-1 power. So this is a geometric sequence, right? That's why I'm putting the n-1 so that when I plug in January, I don't get any interest. I just get my $100 back. So this is what the account will be worth after 48 months. So what does that come out to? So remember, it's under the math key, summation, 48 months, 100 times 1.0025 raised to the, n-1 power. Somewhere in the 5,000s, did you get a 5,000 number? $5,093 and 12 cents. Anyone need help typing it in? You want to make sure your exponent is inside the parentheses. You don't really need any other parentheses other than the ones they give you. If you feel better putting another parentheses as long as you got the 509312. All right, I want to show you the big mistake that students make in this unit so that you don't make it. Compound interest, right? I just want to go back. Let's pretend, you don't have to write this down, that I'm just investing $100 for 48 months at the annual interest rate of 3% compounded monthly. This is a one-time investment. If I say I'm putting in $100 every month, that's when you're going to use summation. If I just say you're putting in $100 one time, remember our compound interest formula, 100 times that 1 plus your 3% divided by 12. That's the same number we're using, right? The 1.0025. But here is when you raise it to the 48th, because that's your number of compounds times your number of years. I want you to notice inside your summation, the number 48 doesn't go anywhere, right? This has to be n minus 1 so that you can plug in 1, plug in 2, plug in 3. If you do a fixed number right here, it's not going to do a summation for you over time. So the 48 is represented differently in a summation than in a one-time investment. So I'm going to put for you on your test next week, that the interest rate is your P1 plus R over N to the NT. And I'm going to write for a one-time investment. Because I don't expect you to memorize the compound interest formula, but you need to know next week that when you do a summation, you don't put 48 here, you put 48 here. And we're going to do practice with that, but that seems to be what always catches people when we're doing compound interest. All right, so number 2 says, instead of $100, how much should you invest each month to have $15,000 at the end of 6 years? So let's think about what we know. We know that we're going to do how many compounds? So I have to do 6 times 12. What's 6 times 12? 72. So it's going to get compounded 72 times, but I don't know what to invest. So I'm just going to put X right there. And I'm going to do the same, it's still the 3%, right? So I can still do the 1.0025 to the n minus 1. Or this is the same as 1 plus 0.03 divided by 12, if you like seeing that better. All right, it would take a long time to guess and check and guess and check. So because you're going from 1 to 72 and you're investing the same amount every single time, it's kind of like the distributive property. It's going to be like this number times 72, and then you're going to do the interest. You're actually allowed to pull the X out front and use it kind of as a multiplier, like it's the distributive property. And we want our answer to be 15,000, right? So this allows us to compute just the interest as a number, because this you could plug into your calculator, right? 1 to 72 of this decimal to the n minus 1, that will be a number now that I pulled the unknown variable out. And then that number we can just divide to the other side of the equation to get X, which is a lot easier than guess and check. So let's go. Math summation. You're going to do X goes from 1 to 72 of just the interest number, the 1.0025 to the n minus 1. So there's no $100 principal because we don't know how much it's supposed to be. We pulled it out front, like taking it out of a parenthesis. This is going to give us some decimal. We're going to take 15,000 and divide by that answer, and that will give me what X has to be. Do I have to invest $150 every month? I have to invest $190.41 to get to 15,000. And this is what your financial advisor will do. They'll say, all right, you want $1 million when you retire. You're going to have to invest about this much every single paycheck to reach your goal based on the stock market being, whatever, 8% annual interest. So you have to do $190.41 as your investment. All right, see if you can do number 3. How much should you invest each year at 5% annual interest compounded annually? So that's going to be a slightly different decimal. Think about that. And you want to have $75,000 at the end of 20 years saved up. So see if you can figure out what you would have to do. How would it change your, interest rate here? I'm going to give you a minute to think about it. The 5% at the end of each of those 20 years. So I took my X out front. I figured out this summation on my calculator. It was about 33.07, but I just left it as the full decimal, took my 75,000 and divided by the full decimal and got the 2268.19. So to me, this is one really applicable application, applicable use of the geometric series, because people don't just invest $100 and hope that they have enough when they retire. They invest $100 every single month or every single paycheck so that they have enough when they retire. So it would be pretty cumbersome to calculate the interest a different way. This allows you to figure out how much you need to invest so that you have the right amount at the end. Okay, here's one more application I want to take a look at. And then I'm going to have you do some practice on 511. This is a chemical treatment that is going into a pond, or some of you have a pool, right? So you shock it with chlorine every couple weeks or whenever it is to keep the chemical level at a certain amount. People treat their fish tanks so that the whatever, it's not chemicals, but I don't know, nitrogen, whatever elements you need for your fish, they treat it once a week, and they know how much is coming out of the water and how much they need to put in the water. Same thing, you don't want to shock it with too much chlorine or too little chlorine. So this is a chemical treatment pond for logs, basically so they don't rot. During the month, 40% of the chemical dissipates. It evaporates or it breaks down, so it's gone. Find the amount of chemical in the holding pond after 3 months, because there's like EPA standards that you can't have too toxic of chemicals in your pond, right? It'll kill the fish. It's bad for the environment. So they want to make sure if you're just pouring in chemicals, it's maintaining some balance, right, for the environment. Here's month 1. You dump in 8 kilograms of the chemical. What happens in February, month 2? You're dumping in 8 additional kilograms. What happens to month 1's? 40% of it breaks down. So now you have 60% of the original 8 kilograms. Then this is January. Now January's had a chance to break down over 2 months. This is now February. It's broken down at a rate of that 60% left. And you dump in 8 kilograms more. So if they want the sum after 3 months, you're really just adding together those 3 terms. To me, it's easier to just type into your calculator, right? Go from 1 to 3 of 8 times 0.6 to the n minus 1. You have 60% remaining at the end of each month. Or you can add up term 1, term 2, and term 3 here. So how many kilograms has been dumped into the pond, or how much is left in total? So 1 to 3, you're giving 8 times 0.6 to the n minus 1. Can someone tell me what's in the pond at the end of month 3? Someone get it? Yeah. 15.68. Why do I know that this is going to be a converging sequence? So this says find the sum for the infinite sum, S sub n. So that could be after 10 months, after 100 months, using our infinite formula. What in this formula tells me it's going to converge to a certain number anyway? This 0.6, right? I'm not doubling it or tripling it. It's getting smaller and smaller each month. So eventually this January 8 kilograms is going to dissipate and it's not going to be left. So I know that together it's going to converge. The infinite formula is a sub 1 over 1 minus r. So I can take 8 over the 1 minus the 0.6. So this is going to be the maximum in the pond. If I go 100 months or 200 months or 300 months, what's it going to max out at? It'll plateau after a while. 20. So 20 kilograms, it'll plateau. It's never going to go higher than 20, on any given month. I'm going to dump in 8, but some will have dissipated. What was the maximum concentration? Oh, will it ever exceed the federal limit? Nope, we're good, right? It would probably be important if you were a chemical engineer that you could justify to the EPA or your boss or whoever for the company, we're not going to get shut down. We're never going to go over the legal limit of the 22 kilograms if they come and test our pond. People who run pools at hotels, they have to test the amount of chemical in that pool multiple times every day, or they could get shut down. So it is important that you know how the chemical's dissipating in the water over time. So no. And then it says, will the maximum ever exceed the state limit of 19 kilograms? And then after how many months will that take place? What I would do is I would put the summation in your y equals menu so that you can just adjust the months in the table. To me, that's easier than guessing and checking. 4 months, 5 months, 6 months. So you just do 8 times the 0.6 to the n minus 1. So if you put x up top, when you get to your table, it'll tell you the number of months that it's gone. So you just go to the y equals and you type the summation into your y equals instead of here. So in which month will it exceed the 19 kilograms? By month what? Yep, I got by month 6. I got month 5 wasn't quite enough, right? It only got to that 18 threshold. It bumped over the 19 threshold in month 6. So by month 6. And I'm not going to put, an application problem about series tomorrow, but I might ask you what it is infinitely going to converge to. But we're going to do some more practice of these before Tuesday. So for the last 15 minutes, I'd like you to, if you want to hold off on 11 maybe, I feel like 12 is a good one though. I'm not going to focus too much on application. If you focused on kind of the front page of the sequence and series practice, I don't know why I put CP, but I used it for CP as well. This one says do it using a calculator, do it using a formula for infinite geometric, find the common ratio, will it converge or diverge? This is similar. There could be arithmetic or geometric, and it could be sequence questions or series questions. Kind of like a 5-question quiz tomorrow.